Welcome everybody to Integrated Math 3. In today's episode, we will be finishing up Chapter 11 with Chapter 11.1.4, which is putting all of our rational expression knowledge together. One might consider this the whole shebang of rational expressions. We are going to be adding and subtracting, multiplying and dividing, getting excluded values all over the place, and we're going to do one example of everything. And so it's just putting all of our skills together because they're going to come in handy when we hit back trig starting next week. So with this example here, let's go ahead and get started. If you would like to pause and try and solve this on your own before I get started, please feel free to solve on your own. Hit that pause button. But without further ado, I'll go ahead and just factor out some GCFs. I got GCFs all over the place. So x squared plus 2x minus 15 in the top left. Factoring out of 4 gets me x squared, not 4x squared, sorry, minus 6x minus 7. This dude, he's normal, so I'll leave him alone. X squared minus 5x, let's see here, minus 14. Cool. Okay, so let's go ahead and just keep on moving this train along here. We're going to factor, we're going to get our excluded values here. So x plus 5 times x minus 3 all over 4 times x, looks like minus 7 times x plus 1, times 2 parentheses x, looks like minus 7 times x plus 2, all over x plus 5 times x plus 2 on the bottom. Okay, cool, we're factored. Once we're factored, we're in a good position to get these excluded values going. Remember, we're multiplying two rational expressions, which means that our excluded values only come from the denominator. So x cannot equal 7, negative 1, negative 5, and negative 2. Again, I just got those from the denominators. Looks like the 7s are going to clean out of here. Looks like I'm going to get the x plus 5s are going to clean out of here, and the x plus 2s are going to vertically cancel. Another thing that's going to get out of here is this 4 and this 2, giving me a 2 down here. So here's what it looks like I have. It looks like I have, as my final answer, 5 times x minus 3 over 2 times x plus 1. And coupled with my excluded values, I think I'm all set. And there you go. That's how you multiply rational expressions together. Let's keep going. Let's go to number 2 here. Number 2. It's going to be a division problem. So let's take a look at this guy here. I'm going to do 12x plus 6 over 21x squared minus 21 divided by 6x squared plus 9x plus 3 all over 7x cubed minus 7x squared. Okay, again, lots of GCFs going on all over the place. And I'm dividing. So the first thing I'm going to do is I'm going to take that second fraction and I'm going to flip them. Of course, please pause, write this problem down if you need to. And if you want to get ahead of me, keep it on pause afterwards. So we've got 12x plus 6 here if I'm going to continue moving forward. 21x squared minus 21 times 7x cubed minus 7x squared over 6x squared plus 9x plus 3. Okay, let's get some factoring going on here. So I'm going to go and just factor out the 12 here. Oh, sorry, not 12, 6. Factor out a 6. That'll get me, looks like 2x plus 1. Here I'm going to factor out a 21, and that'll get me x squared minus 1. Of course, I've got a difference of squares in the bottom left. If I factor out a 7x squared here, that leaves me on the inside with an x minus 1 on the top right. And then in the bottom right, I can factor out a 3. That'll give me 2x squared plus 3x plus 1. And I believe that will factor one more time. So let's go ahead and clean this guy up a little bit. I'll switch colors, maybe sky blue. I've got 6 parentheses, 2x plus 1 over. The 21 will stay there, but this is a difference of squares. So I've got x minus 1 times x plus 1. On the top right, I believe the top right was completely factored from the middle step here. And then the bottom right can factor trinomially. So I'll do 2x and x. I'm figuring it's a 1, a 1, a plus, and a plus. Okay, so let's talk excluded values. Excluded values, we were dividing, which means they will come from the bottom of the left and the whole shebang of the right. Hopefully we remember that. So the excluded values are going to be x cannot equal plus or minus 1. I got that from the bottom left. From the top right, the 1 is already covered, but x cannot equal 0 because of the x squared here. And then x cannot also equal negative 1/2, because of this bottom deal here. And of course, the negative 1 is covered under this x plus 1. So once we've got our excluded values, let's clean house. 2x plus 1, gone. X minus 1, gone. X plus 1, not gone, because they are horizontally from each other. So those are not gone, so please don't make that mistake. Let's take a look. I'm going to switch colors here a little bit because we're getting a little too blue here. It looks like the 21 and the 7 are going to be kind of gone, giving me a 3 down here. Now, the 3 and the 3 are not gone, but the 6 and the 3 are, in fact, gone, giving me a 2 up top. So here, let's take a look at everything that does not have a slash through it. Up top, it's going to be 2x squared over, looks like 3 times x plus 1 times x plus 1, but I'm going to go ahead and call them x plus 1 quantity squared. And I think that is where this problem ends. So again, what did we do? We flipped, we factored, we got our excluded values from the bottom left and the whole shebang on the right. We canceled a bunch of crap out of there, and then we multiplied everything after we were done. Hopefully that makes a certain amount of sense. Let's keep on moving forward. Now, this problem here is another division problem. However, he's going to be structured in a way that is going to be a little bit odd. So what I'm going to do is I'm going to do 6y, oops, this is example 3 here, 6y squared minus 6 over 8y squared plus 8y all over 3y minus 3, that's a bad 3 over 4y squared plus 4y. Okay, 4-layered fraction, not too bad. It does look threatening, but let's just make sure we're clear about something. I'll go ahead and call him fraction 1, the top guy. I'll go ahead and call him fraction 2, the bottom guy. Hopefully it makes sense that it's going to be fraction 1 divided by fraction 2, and when we divide fractions, we take the second guy and we flip the second guy, and then we multiply. So, in the context of this particular number 3, I'm hoping it makes sense that what we have is 6y squared minus 6 over 8y squared plus 8y times the bottom guy upside down. So it'll be 4y squared plus 4y over 3y minus 3. I'm hoping that makes a certain degree of sense there. So at this point, if you'd like to pause and finish up the problem, please feel free to do so. I will go ahead and continue moving forward. On the top, I'll switch to yellow. I've got factoring out of 6 giving me y squared minus 1. On the bottom left, I'm going to factor out an 8y giving me y plus 1. Top right, factor out of 4y gives me y plus 1. Bottom right, 3 parentheses y minus 1. Okay. Let's go and factor again if we need to, and we do need to. That'll be 6 parentheses y minus 1, y plus 1 over 8y times y plus 1 times. All this stuff was already factored, so he can just kind of come down 3y minus 1. Okay, let's talk excluded value. Again, what were we doing the entire time? We were dividing, which means my excluded values come from the bottom left and the whole shebang of the right. So y cannot equal, looks like from the bottom left, 0 and negative 1. From the top right, again, 0, negative 1, so we're covered there. And then from the bottom right, plus 1. So it looks like my excluded values are all accounted for. Let's cancel stuff. Goodbye to the y plus 1s. Goodbye to the y minus 1s. Goodbye to the y's. Goodbye to the 4. Goodbye to the 8, kind of. Goodbye to the 6, goodbye to the 3. I get a 2 up top, and guess what? The 2's cancel out completely. Oh, whoops, that is bad cancellation. That is not a 21. And all I have that was not crossed off, and look very carefully, it looks like one of those magic eye posters, right? But the only thing that wasn't crossed off was a y plus 1. He's the only thing that survived that entire onslaught. It's kind of cool, actually, that all this stuff could cancel out and you'd end up with something really, really simple. So there is your answer. So the 4-layered fraction, pay attention to those. We do like them. So, all right, let's move on to addition and subtraction. And here we are with a subtraction problem. So please remember, we are subtracting now, which means we need a common denominator in order to subtract successfully. So before I get a common denominator, it might be prudent to factor the bottom left, and that will allow you to see what the common denominator is much more quickly. So let's identify what that common denominator is. Looks like they both have an x minus y in common, but the front runner, the left fraction, is ahead by 1x plus y. So hopefully it makes sense that x minus y times x plus y is your common denominator. So that will cover here. So what did the right side need in order to become the common denominator? He needed an x plus y. The left side didn't need anything, so he became a 1. So 7x when I distribute him in, and again, we covered this in the last example, in the last episode. A 1 is not distributing in. A negative 1 is. So that'll be minus x minus y. So now the 7x's and the x's are going to subtract each other, so 6x minus y over x minus y over x plus y. And of course, I totally forgot to do the excluded values, but we'll do that at the end here. X cannot equal plus or minus y. Otherwise, you'll be dividing by 0, and that's bad. And here we are at the last example. It's going to be another 4-layered fraction, this time combining some addition and subtraction with some multiplication and division. So if you want to attempt this problem on your own, feel free to pause and get ahead of me. It's not a big deal. But what I'm going to do is I'm going to go and take care of the top only. The top only, I need to add him, which means I need a common denominator. Hopefully the common denominator is somewhat obvious at this point. It's going to be x plus 2 times x minus 5. So what did the pieces need? This guy needed the x minus 5. This guy needed the x plus 2. And I got to do it to both the top and the bottom. So what I've got is I've got x minus 5 plus x plus 2. And again, that's all over. I have not messed with the bottom yet. That's going to be 2x squared minus x minus 3 over x squared minus 3x minus 10. Let's go and combine some terms here. So it looks like I've got 2x minus 3 up top over x plus 2 times x minus 5. Now, before I carry down the bottom as is, remember, I'm dividing the whole shebang of the top divided by the whole shebang of the bottom, which means I can actually call him multiplied by x squared minus 3x minus 10 over 2x squared minus x minus 3. So let's go and factor the right side now. 2x minus 3 over x plus 2 times x minus 5. That's a plus. Times, let's factor the top. So x looks like minus 5. X plus 2. Oh, awesome. I feel like something cool is going to happen. 2x and x. I'm thinking a minus 3 and a plus 1. Okay, what's going to get out of here? Looks like the whole shebang of the bottoms are going to go away. And then the 2x minus 3's are going to go away, leaving me with 1 over x plus 1. Now, I did, in fact, forget, once again, the excluded values, but luckily we can kind of look at the pre-crossed out fraction here and figure out what it is. So remember, it's a division problem, which means the whole shebang of the right side is going to be an excluded value potential, and the bottom of the left side. So that's going to be, looks like x cannot equal negative 2, 5, looks like 3 halves and negative 1. And there you have it. That is all of rational expressions put together. Hopefully that makes sense. As always, please leave comments or questions in the comments area. Congratulations on finishing Chapter 11. We will see you all in the next chapter, which is the revisitation of trigonometry.